Welcome to clickmyproject.com. We will discuss about the product for lung nodal classification with multi-level batch-based context analysis. Our abstract is lung cancer is a major worldwide problem that seriously endangers people's life. The survival of patients with lung cancer is strongly dependent on accurate of early diagnosis. Approximately 20% of medical cases with lung nodal represent cancers. Therefore, diagnosing malignant nodule from benign nodules is essential for the detection of lung cancer. Recently, image-based diagnosis in clinical setting has focused on the automated computation of quantitative measures to investigate the correlation among different types of lung nodules. Propose an automatic method to classify lung nodules into 4 different types. Example: well circumference, juxtavascular, juxtapleural and pleural tail. Additionally, since the morphology of lung nodule forms a continuum between the different types, our proposed method is support to previous method that classify single nodule into single type. First, a weighted similarity network is constructed based on the SVM with probability estimate, turning the 128 length shift feature to a 4 length of probability vector against in the 4 types. Then the classification of nodules while identifying those with overlapping types is made using the weighted correlation method. We evaluate the proposed method low dose CD image from LCAP. Our results show there is a more overlap between the well circumference and juxtavascular and between the juxtapleural and pleural tail. Also, quantitate the comparison among the various methods demonstrate highly effective nodal classification result to identify the overlapping nodal types. In this paper, we propose a novel classification method for 4 types lung nodules. Example for well circumference, vascular, juxtapleural and pleural tail. In low dose computed tomography scans, the proposed method is based on the contextual analysis by comparing the lung nodule and surrounding the automation structure, and has with 3 main stages. An adaptive batch-based division is used to concentric multi-level partitioning. Then a new feature set is designed to incorporate intensity, texture and radiate information for the image batch feature description, and then contextual latent semantic analysis based classifier is designed to calculate the probabilistic estimation for the relevant images. Our future work to proposed method was evaluate the publicly available dataset and clearly demonstrate promoting the classification performance. Next, we will discuss about the flow diagram for the product. First, the input image get to the database nodal images, then the nodal input image to going to the pre-processing step. The pre-processing step used in the 2D order static filter. The 2D order static filter considers each pixel in an image in turn and look at its nearby neighbor to decide whether or not it is representative of surrounding. In signal processing, it is often desirable to able to perform some kind of noise reduction on an image or a signal. 2D order static filter is one of the best noise removing filter. It is a non-linear digital filtering technique. Then go to the partition method. The partition method used in the adaptive partition method. Our method is built upon the batch-based image representation. The current approaches are usually batch-based with fixed shape and size, such as dividing the image into the square batches. Then the concentric level partitioning model is constructed based on the distance from the batches to the centroid of the lung nodule. The shape and size of our batches are derived adaptive according to the local intensity variation instead of being predefined by rigid partitioning method. Then go to the superpixel segmentation technique. The superpixel clustering method formulation is process of dividing an image into the multiple segments, which can be incorporate local spatial information to reduce the spurious labeling due to the noise. In particular, quick-shift is a mode-seeking algorithm that can be used to partitioning the image into set of superpixels forming a tree of links to the nearest neighbor, increase the estimate of density. However, due to the small size lung nodule, poor partitioning is often obtained whether directly applying to the quick shift method. To tackle this problem, we employ the quick shift is an interactive way of image amplification and downsampling the method. Then go to the values of feature extraction window. The feature extraction process generates 128 vector for each key point. Since shift is invariant to image translation, scaling, rotating and elimination for the changes, the shift feature algorithm is robust to local geometric distortion. It provides the valuable lung nodal data. In our cases, we extract to only the 128 length vector near the centroid for each patch, especially since the shapes of the extracted patches are not uniform. We selected the smallest rectangle sub window to cover all pixels for each point, then ran the shift on this window. Then go to the SVM classifier method. At the same time, the input nodal image going to the pre-processing step. The pre-processing step using the same 2D order static filter. Then go to the partition method. The partition method is in the adaptive partitioning, and go to the superpixel clustering method. Then the feature extract value. The feature extract value using the shift feature algorithm. Then go to the SVM classifier method. The SVM classifier method, our proposed method. The proposed classifier categories of the lung image based on the concentric level partitioning and the extract feature. The level nodal probability of level context probability are combined with the classify the image. To evaluate the design or design the classifier comparison where the construction our method SVM classifier, the SVM classifier on label nodule and the SVM classifier with context analysis. Overall classification rate also measure the recall and precision on each values of the accuracy type. Then go to the identification process, which type of nodal to be identified by this process. Then finally classify the output. The lung nodal to be any four types to select any one of the type. Final output. Next we will see about the output for the product. Then the main file to be run the output. Then go to the output for the lung nodal classification with multi-level batch-based context analysis. First, browse the input lung nodal image. Then browse the any one of the lung nodal image. Then display the input image for the lung nodal. Then go to the pre-processing step. The pre-processing step using the 2D order static filter. Then go to the next window. The next window is image partitioning window. There are two types of partitioning to be applied for this method. The rigid partitioning method. Then go to the adaptive partitioning method. The adaptive partitioning method to be displayed. Then process for the adaptive partitioning method. Then go to the next window. The next window is multi-level partitioning window. The partitioning window, they have clustering method and the iterative segmentation process. The clustering method will be cluster the superpixel clustering image. Then iterative segmentation, this segment in the 4 type of segment for the clustering input image. Then go to the next process. The next process is the shift feature extract window. The shift feature extract window to be used to input for the shift feature values. Then points for the shift feature points. Then graph the histogram for the input shift feature descriptor diagram. Then go to the shift feature table for the input query image. Then go to the next process. The next process is identification analysis process. The identification is which type of lung nodal type to be classified. The lung nodal is juxtapleural type. Then go to the analysis for the type. The precision value is 1 to display the graph. The precision and existing adaptive partitioning and rigid partitioning method to be classified. Then go to the recall value. Then recall value is 0.9933. Then go to the graph to be displayed. Graph adaptive and rigid partitioning graph to be displayed. Then go to the accuracy value. Accuracy value is 95% for this method. Then go to the adaptive partition, rigid partition, accuracy graph to be displayed. Thus the output for the lung nodal classification with multi-level batch-based context analysis.